Hi, everyone. Quite the introduction. I'll not introduce myself because I have only 10 minutes, so let's jump right into the topic. So, in the last couple of years, reactivity has been the hot topic of the front-end world. After years of civilized discussion on Twitter, all of the framework creators are coming to an agreement on the topic, except one. To dig into the details, let's first define what we are talking about. And no, it's not something easy like chemistry, biology. We are dealing with something much trickier, front-end development. Firstly, we need to understand what the problem is. When the first front-end frameworks were introduced, they solved two very important issues. They enhanced user experience by creating websites that were dynamic, highly interactive, and performed like native apps. On the other hand, they also improved developer experience, empowering developers to create such sophisticated applications. Reactivity sits at the core of these frameworks, playing a crucial role for both developer experience and user experience. It ensures that updates to the UI happen automatically without developers needing to manually rewrite code each time. In its simplest form, Markov Frontend Masters describes reactivity as reactivity is how systems react to changes in data. When data changes, you do things. Expanding on this, the view documentation
Hey,
defines
Rosen.
reactivity. Yep.
Sorry to interrupt. Are we supposed to be seeing a share screen? Because we are
Oh,
not seeing it back.
I'm really sorry. Yep.
No worries. We know you have some important things to say and didn't want to miss it.
Yep. Should I start from the beginning or just continue?
I would start from the beginning so that way we get the
Yeah,
entire thing. Thank
sorry
you.
for that. Okay, just a second. So quickly, let's go through the beginning again. Yeah, the topic of your activity. It's been the hot topic in the last couple of years. Um, when the first frontend, just a second. Yeah, there's been a lot of discussion, and it seems like the framework creators are coming to an agreement. First, we need to start with the definition, and we are going to go through what the problem does reactivity solve. So, yeah, as I said, now you can see it. When the first front-end frameworks were introduced, they solved two important issues. One was developer experience, and the other was user experience. The users wanted dynamic apps that felt like native apps, and the developers needed tools to develop these sophisticated applications. Reactivity sits at the core of these problems and sits at the core of these frameworks. It helps developers update the UI automatically without the needing to manually rewrite code each time. So now let's go to the definition. Markov Frontend Masters describes reactivity as reactivity is how systems react to changes in data. When data changes, you do things. Expanding on this, the Vue documentation defines reactivity as a programming paradigm that allows us to adjust to changes in a declarative manner. The declarative part is quite important and explained well in the reactive programming as a general programming paradigm. Let's see an example. In an imperative programming setting, A equals B plus C would mean that A is assigned the result of B plus C in the instant the expression is evaluated, and later the values of B and C can be changed with no effect on the value of A. Now imagine instead a special destiny operator. In reactive programming, using the destiny operator, we will write A's destiny is B plus C, and that would mean that the value of A is automatically updated whenever the values of B or C change, without needing to explicitly repeat the assignment each time. Now, how do we implement reactivity in vanilla JavaScript? You can make a single property reactive using object-defined property, setting up getters and setters to execute code when a property is accessed or modified. You can also handle reactivity for the entire object using proxy. A proxy allows you to modify the implementation of the object using handler functions, known as traps, presumably because they trap calls to the object. Or reactivity can be implemented using an event emitter, where you listen for changes and update the UI in response. There are many ways and strategies to achieve this using vanilla JavaScript. and there are articles that provide great insight into the different techniques. Now, let's rewind to 2010 when, within a span of 3 months, 3 popular frameworks emerged, each offering a distinct version of reactivity. First came Knockout, introducing initially two concepts: observable for state and computed for side effects, and later they introduced a third concept, pure computed for derived state. Backbone's reactivity was more akin to the event-based example we saw in vanilla JavaScript. The framework used a model view architecture, where models, which represent the data, and views, which represent the UI, are separate but interconnected components. Models emit events when their attributes change, and views listen to these events to update the UI automatically. Angular introduced data binding, automating much of the DOM updates and data synchronization through a digest cycle, a loop that monitors changes in watch variables and updates the view whenever a change is detected. However, if not used carefully, Angular was prone to performance issues due to extensive monitoring of data changes. The patterns often felt clunky, either derived from server-side models like MVC or from older jQuery practices. Moreover, misusing these powerful but flawed techniques often became a food gun. React introduced a solution to these issues with its unidirectional data flow and virtual DOM. Every time there is a change in state, a new virtual DOM is created and compared with the previous one. Then only the necessary changes are applied to the UI. This method makes it clear what triggers an update, what the result of the updates are, and how they are applied. But wait a second. We've discussed reactive patterns in vanilla JavaScript that update precisely the needed element. Now we're moving to these dirty checking systems. Are these even truly reactive? There have been many talks and articles about how React isn't reactive even by their own standards. Angular is further from that. This is why, in order to keep everyone on the same topic, we introduce a spectrum or a dimension of reactivity, ranging from coarse to fine-grained. It goes like this. Coarse-grained reactivity means that the framework has to execute a lot of application or framework code to determine which DOM nodes need to be updated. Fine-grained means the framework does not need to execute any code and knows precisely which DOM nodes need to be updated. There are trade-offs to each solution between performance and ease of use. I will let you guess which side is preferred by us, web devs. When Vue appeared, it quickly became popular for its intuitive and efficient reactivity system. When you assign a plain JavaScript object to a Vue's instance as its data option, Vue.js processes all its properties and converts them into getters and setters using object-defined property. These getters and setters help Vue track and notify changes in properties. Each directive for data binding is linked to a watcher that monitors touched properties. When activated, the setter prompts the watcher to update the DOM. Reactivity in Svelte was achieved through a reactive assignment. When the state of component was updated, Svelte would automatically rerun the component code to reflect these changes in the DOM. Unlike frameworks like React, Svelte 1 didn't use virtual DOM. Instead, it compiled components into highly efficient imperative code that directly updated the DOM. This meant that Svelte could make updates very quickly and efficiently. Solid brings us full circle to the early days of reactive frameworks, like Knockout.js, especially through its use of signals for state management. Signals in Solid are a pair of getter-setter functions that manage reactive state. When a signal's value is accessed, Solid.js tracks the current function as a dependency. Upon updating the signal, Solid.js efficiently triggers updates only in the functions or components that depend on it. This leads to more targeted and efficient UI updates. The combination of simple reactive primitives and compile time optimizations in Solid makes it highly performant. My website is slow, but it's not my fault. Most improvements in CPU performance over the last decade have come from adding more cores, but since V8 JavaScript execution is single-threaded, it doesn't fully benefit from these additional cores. So to enhance performance, we need to focus on improving the code itself. This need for better performance is driving major changes across popular frameworks. In 2019, Svelte rethought its approach to reactivity, moving from manual state setting to a system that compiles and abstracts reactivity. Recently, with applications growing more complex, Svelte has shifted its emphasis to runes or signals to better manage reactive states. Similarly, Angular is evolving to become more performant by using signals. This transition aims to shift Angular from a coarse-grained Zone.js-dependent dirty checking framework to a more modern one. Vue has also recognized the virtual DOM is not the most efficient approach and is shifting to Vapor, a new compilation strategy that eliminates the use of virtual DOM. React, while not adopting signals, has acknowledged the need for performance enhancements. After initially adopting the fiber architecture to improve reconciliation, React is now focusing on compilation to optimize performance and reduce bundle sizes. There's an interesting story unfolding as all major framework creators and contributors have come together to discuss integrating signals into ECMAScript. Just like async await and promises, signals could become a shared feature, enabling tools like dependency graph visualization and debugging across different frameworks. Are signals truly dependency? Will React give in and join the others? I don't know how frameworks will evolve, but I do know that it's up to us to prioritize user experience in the reactivity equation. And now that you've seen it, actually, I hope you liked it. Thank you for your time. These are my handles where you can find me. I try to make YouTube videos every 2 weeks, and I try to post articles every month. Thank you for your time.